All right, we are starting a new unit on similarity. So a little vocabulary today and review of how to solve proportions. Right. When you are asked to write a ratio, I want you to think fraction, but there are other ways to show ratios. All right. A ratio is any two quantities when they are measured in the same units are compared. So you may see a ratio written as A to B. You may see it written with the colon, or you might see it written as a fraction. Again, if in a problem you're asked to write a ratio, fraction is the preferred way. All right. You're always going to make sure your fraction is in lowest terms. If you have a fraction typed into a graphing calculator, you can go into your math function, and then the very first feature, it says frac. So math, and then hit enter, and then hit enter again. So a lot of times you'll hear teachers say, math, enter, enter. That's how you can reduce fractions and put them in lowest terms. All right, I'm just going to make up some numbers here since we're not live. But let's say that we had 10 girls in our class and 15 boys. Okay, so if you were asked to write a ratio of girls to boys, the first is your numerator, and the boys would be your denominator. Okay, so we would do 10 to 15, and then we would reduce that. Both are divisible by 5, so it would reduce to 2/3. If I wanted the ratio of boys to the entire class, again, boys would be my numerator, so that's 15. The entire class I'd have to combine, so 10 plus 15 is 25, and then when we reduce that, we get 3/5. Okay. An extended ratio is when we're going to compare 3 or more quantities. So you'll see it written like this, A to B to C. There's no way to write a fraction with 3 numbers like that. Okay, so this is how this works. So it says the ratio of the measures of the angles in a triangle are 6 to 7 to 5, and it wants the measure of all the angles. Well, what do we know about the measures of the angles in a triangle? We know they equal 180. So what we're going to do is stick a variable behind each one of these numbers. So one of my angles would be 6x. The next one would be 7x. The third one would be 5x. And the sum of those 3 I know equals 180. Okay, so add your like terms. So we've got 18 x's equals 180. Divide by 18, x is 10. It didn't say stop at solving for x. It wants the actual measures of each one. So if we substitute 10 into each of the 6x, 7x, and 5x, then we've got the measures would be 60 degrees, 70 degrees, and 50 degrees. That's what we're looking for. All right, number 3 says the ratio of 2 complementary angles is 5 to 10. All right, well, what do we know about complementary? We know they equal 90. So again, we're going to put a variable behind each. So 5x plus 10x, I know those together are complementary, so this time they'll equal 90. So I've got 15x's equals 90, divide by 15, x is 6, substitute those back in. So one of our measures is 30 degrees, 6 times 5, and the other will be 60 degrees. There are no names given to these angles, so I can't put the measure of angle A equals in front of anything. All right, those are extended ratios. Proportions. A proportion is an equation that states that 2 ratios are equal. We use what's called the cross product property to solve proportions. So for any proportion where you've got A over B equal to C over D, so 2 fractions equal to each other, then we cross multiply. So I'll do A times D, and I'm going to set that equal to what I get when I cross the other way, b times c. That's the rule. So in number 4, I'm going to cross multiply. So I've got 5 times x, which will be 5x, and that will be equal to the 4 times 7, which is 28. All right, divide by 5. This does not go in even, so I'm going to leave it, whoops, crazy 5, leave it as a fraction in lowest terms, and that doesn't reduce. So I'm just going to write it again since that's ugly. So 28/5 would be my answer. If you changed it to a decimal, as long as it's not a repeating decimal, that would be okay. Of course, you're going to be solving more where there's a little algebraic expression, but the rule is the same. We still cross multiply, so I've got 3 times y is 3y equals. Now, when you have this expression, we're just going to put parentheses around it, and then that tells us we're going to need to distribute. So I've got 3y equals 2 times the quantity y plus 2. So 3y equals 2y plus 4. Subtract the 2y. So y equals 4. Okay. Now, the type of problems you're going to solve in this unit, almost every single one requires a proportion to be set up and solved. Today, we're just kind of reviewing the type of problems that you should already be able to do with proportions. So it says a recipe calls for 3 cups of flour for 48 cookies. So the question is, how much flour is needed for 72 cookies? Now notice we've got different units. We've got cups of flour and we have cookies. So when you go to write your ratio, these are not going to be in the same unit, but you pick the order in which you're going to do it. Now, these are our notes, so I'm just writing over here. This is how I'm going to write all my ratios. It's always going to be cups of flour in my numerator over the cookies, number of cookies that correspond with it. So if I'm told that 3 cups of flour yields 48 cookies, all right, I'm going to set that equal. The question here is how much flour. So that goes in my numerator, and the 72 goes in my denominator. So it's always cups of flour over the number of cookies. All right, then I could cross multiply. So we've got 48x equals, let's see, 216. And then divide that out. So 216 divided by 48 is 4.5, 4.5. Now, I'm not going to make you write a sentence, but I expect you to put the proper units on these since they are word problems. So that 4.5 represents cups of flour. All right, one more. A picture has a length of 6 inches and a width of 4 inches. You want to enlarge a picture so it is 20 inches long. How wide will the picture be? So our units here, we're using length and width. All right. Now, I don't have to go in that order. If you wanted to do width over length, you could, but each fraction that you write must continue with this pattern. So if I've got a length of 6 and it's paired with a width of 4, all right, this 20 is telling me that that's 20 inches long. That is length, so the 20 goes up top, and it's the width that I'm trying to find. So I'll just use a variable of W. All right. Once I've got my ratio set up, I cross multiply. So we've got 6W equals 80. And then when I divide by 6, all right, we get 13.3 repeating. All right. I don't want to use repeating decimals. Hopefully you remember 0.3 repeating is 1/3 as a fraction. And this is inches. So it's going to be 13 1/3 inches long. This is the only type of problem where we will use what I call a mixed fraction. All right, but we don't want to just do 13.3. We want to change that to a fraction. If I fract that, the calculator is going to tell me that that is 40/3 inches. All right, so that is also correct, but this is the better answer. That's the one that makes the most sense. Okay. Now, in geometry, how do we use ratios? Well, it says the ratio of 3 side lengths of the triangle is given, solve for the variable. Now, I showed you earlier, all right, where we did angle measures. We know that those equal 180. We did one for complementary. We know those add to equal 90. But the side lengths do not add to equal anything in particular. So what we're going to do in order to do a problem with the side lengths is I need to know what those 3 side lengths would actually be, all right, represented by. And so in the picture, I see that side AB and side AC are both 3x, and side BC is x plus 4. So this is what we're going to do. The ratio, I'm told, goes side AB to AC to BC. All right, so I'm going to use the 3 numbers they give me, the 3, 3, and 5. These are going to be my numerator. So I'm going to have 3 over equals 3 over equals 5 over. And then I go to the picture. So AB goes with the first 3. 3x is that length, so that goes underneath. The next one is the same. All right, BC is my third one, that's x plus 4. Now, this is obviously an isosceles triangle, all right, and I did pick this problem specifically because when you end up with 2 ratios that are identical, all right, we can't just use these 2 to cross multiply because you're going to end up canceling everything out. All right, so of these 3, we need 2 that we can actually cross multiply and solve. So you have to make sure you take one that's the same and one that's different. Right? This doesn't happen often with the isosceles triangles, all right, but when it does, pay attention. So we don't want to use this first one. So we're going to cross multiply here. So I've got 3 times a quantity x plus 4, and that's going to equal 5 times 3x, which will be 15x. So I'm going to distribute. So we've got 3x plus 12 equals 15x. All right, I'll bring the x over here to the right so that I can combine my like terms, and then last we'll divide by 12. So x comes out to be 1. And all it wanted us to do was to solve for the variable, so I can stop there. If it wants the length of each side, I would just substitute it back in to figure out what they are. Right? So these are the type of problems you're working on today. You're writing ratios, solving extended ratio problems, and solving problems using proportions. Right? You should be ready to practice.